Alright, welcome back everybody. In this video we're going to look at the examples from the Power Series lesson. And there was a whole page of information that you should have read through about how a power series for 1 over 1 minus x developed, and comparing that to its partial sums and checking out convergence of that, and some general definitions for power series and centered at 0 and power series centered at x equals a. In this example, what we're going to focus on is we're going to focus on developing power series from a given power series and developing power series from the sum of a geometric series, the a over 1 minus r. So I'm going to look at example A, and I'm going to look at it in two different ways. The first way that I'm going to look at it is by using a known series and using substitution to figure out this series. So if we know that 1 over 1 minus x is represented by this series on its interval of convergence, if I want to find a series for 1 over 1 plus x, really all that is it's the series 1 over 1 minus negative x. And so what I can do is I can take this series right here and substitute everywhere where there's an x, I can replace it with a negative x. And if I do that, this becomes 1 minus x plus the quantity negative x quantity squared plus the quantity negative x quantity cubed, etc., all the way up to negative x to the n, and then beyond. And what I'm going to see when I see this is if I simplify this, it turns into the series 1 minus x plus x squared minus x cubed plus x to the fourth minus x to the fifth, etc., plus negative 1 to the n, x to the n. And that is a power series that represents the function 1 over 1 plus x. Now, the interval of convergence of our original series was that negative 1 is less than x is less than 1. And since we substituted negative x in there, I can find the interval of convergence of this new series by substituting negative x into the interval of convergence. And when I do that, I just divide both sides by negative 1. And you'll see that the interval of convergence for this is also from negative 1 to 1. All right? So that's one way that I could handle this problem. Another way that I could handle it is by just looking at this in terms of a over 1 minus r, and then this is a series where a is equal to 1, r is equal to negative x, and then that series is just a plus ar squared, etc., which gives me this exact same series. And the interval of convergence has to be where, pardon me, yeah, I should have just kept writing, where the absolute value of this is less than 1, and we solved that right down here. So that's another way of thinking about it. We can think about it in either of those two ways, and it'll work out just fine for us. All right? So let's see, which way should I think about this one? Should I think of it as a over 1 minus r, or should I think about it in terms of substitution with what we've already got? Well, in part A, we just found the power series that represents 1 over 1 plus x, and this power series is just x times 1 over 1 plus x. So another way that I can develop a power series from another power series is by multiplying through by the same factor. And so all I'm going to do in this one is I'm going to take the series that I found in part A, and I'm going to multiply through by an x. I have a really hard time putting the right parenthesis here since those terms go on and on forever, but I think that's just a personal quirk. I'm going to multiply through that entire series by x. And that gives me a new series for this particular power series. And there you go. There's a series for x over 1 plus x. Now, as far as the interval of convergence goes, all we're really doing here is multiplying a series that we know by another factor, which doesn't change the interval of convergence at all. This is still a geometric series where it's still going to converge for the same interval of convergence as we had in part A. And so there's our interval of convergence for this one. All right, let's go ahead and look at part C. Find a power series that represents 1 over 1 minus 2x. What's the interval of convergence? Let's do it the other way this time. We're going to say A is equal to 1, R is equal to 2x, and so my series is going to be A plus AR plus AR squared plus AR to the third, etc., etc., plus A times R to the n, and there's my power series. Represents 1 over 1 minus 2x. And now as far as my interval of convergence goes, with a geometric series, as long as the absolute value of r is less than 1, it converges. And so I'll solve this inequality to give me my interval of convergence. Divide all the parts by 2. And there's my interval of convergence for this series. Alright, that worked pretty well. Alright, let's go on to part D. Find a power series that represents 1 over x. And in order to make this easier on ourselves, we rewrite 1 over x as 1 over the quantity 1 plus x minus 1. I'll do a over 1 minus r again to do this one. A is equal to 1. R is equal to the opposite of the quantity x minus 1. And so my power series here is going to be A plus A times R plus A times R squared plus A times R to the third, etc., etc., all the way up to A times R to the n. And my interval of convergence, in order for this to converge, the absolute value of the opposite of the quantity x minus 1 has to be less than 1. So negative 1 is in between that. Multiplying all three parts by negative 1, you get that. And then adding 1 to all three parts, we end up with our interval of convergence being from 0 to 2. So there's our series for 1 over 1 plus the quantity x minus 1, and there's my interval of convergence. A power series for 1 over 3x, representing it as 1/3 times 1 over 1 plus x minus 1. Well, now we have the same series that we just looked at up here in part D is part of the series expansion, and all we're doing is multiplying that by 1/3. So all I'm going to do to write the series is multiply the series that we got in part D by 1/3. It's a really bad 3. There's my series, and my interval of convergence. Since I didn't change the geometric series here at all, I just multiplied by that constant 1/3, my interval of convergence is going to remain the same as it was in part D. And there's my series and my interval of convergence. Okay, so hopefully you guys can do a few of these and really get it under your belt, the idea of how we build these series based off of either substitution or multiplication, or even going back and using the geometric series formula to come up with that. Alright, that's the end of this video. See you guys next time. Have a great rest of your day.